For most of history, gemstones were trusted for one simple reason. Experts said they were real. That trust shaped what was collected, what was valued, and what was quietly dismissed. If a stone didn't fit the rules, the color was wrong, the structure was unfamiliar, or the story didn't make sense. Experts assumed the same thing. It couldn't be natural. It had to be fake, or at least, not worth taking seriously. But here's the uncomfortable truth. Some of the stones experts rejected weren't wrong. The assumptions were. In this video, we're counting down 10 gemstones that experts once doubted, dismissed, or misclassified, and later had to completely rethink. Not because of trends, not because of marketing, but because science eventually caught up. As you watch, pay attention to one question, and I want you to answer it in the comments before the video ends. When experts get something wrong, who decides what real actually means? Let's begin. Ranked 10th. Fire opal. The opal experts didn't believe in. For decades, fire opal created an uncomfortable problem for experts. Not because it was unstable, not because it was synthetic, but because it refused to behave the way opal was expected to behave. In classical gemology, opal meant one thing above all else: play of color. That shifting rainbow effect wasn't just admired, it was treated as proof. If a stone didn't display it, many experts quietly questioned whether it belonged in the opal family at all. Fire opal didn't flash. It glowed, clear to translucent, orange to deep red, sometimes so pure it looked more like molten glass than a gemstone. And that was the first red flag. At a time when glass imitations were everywhere, fire opal's clarity worked against it. Early experts weren't accusing anyone of fraud, but they hesitated. Stones that look this clean, this vivid, usually hit a trick. Here's the first uncomfortable question experts never asked out loud. If fire opal had been discovered today, would anyone doubt it at all? Or was it judged unfairly simply because it didn't match what experts already believed? For years, fire opal lived in a strange limbo. Some catalogs excluded it entirely. Others listed it as decorative, not gem grade. It wasn't rejected outright. It was quietly sidelined. Not because it failed scientific tests, but because it failed expectations. As mineralogical analysis advanced, researchers began examining fire opal beyond appearance. What they found was simple and humbling. Fire opal wasn't missing anything. Structurally and chemically, it was natural opal. Hydrated silica formed through the same geological processes. The difference was internal structure. Without the microscopic spheres that create color play, fire opal expressed itself through body color instead, often intensified by trace iron. Nothing artificial, nothing added, nothing fake. The stone had always been real. The definition was wrong. Once this became undeniable, classifications changed quickly. Major gemological institutions updated their standards. Collectors began reassessing stones that had been dismissed for decades, and fire opal's reputation quietly reversed. Today, it isn't valued for spectacle. It isn't judged by how loudly it performs under light. It's appreciated for glow, depth, and presence. The same qualities once used to doubt it. That reversal matters, because fire opal wasn't redeemed by hype or trend. It was validated when experts accepted a harder truth. Sometimes the mistake isn't the stone. It's the framework used to judge it. So here's a question worth thinking about, and I want you to answer honestly in the comments. When it comes to gemstones, what matters more to you? How a stone behaves or how long experts believed it was real? Ranked 9th, Moldavite. The stone experts almost wrote off as glass. For a long time, Moldavite wasn't taken seriously, not because it lacked beauty, not because it was unstable, but because it looked too ordinary to be extraordinary. Green, pitted, irregular. To early experts, Moldavite didn't resemble a gemstone at all. It looked like glass, the kind left behind by industrial processes or human activity. And that assumption shaped its fate for decades. When Moldavite specimens first circulated in Central Europe, many experts classified them as slag glass or accidental byproducts of ancient manufacturing. The surface texture was rough, the shapes were chaotic, There were no crystal faces, no symmetry, no elegance. By gemstone standards of the time, Moldavite broke every rule. Here's the first uncomfortable question experts avoided. If Moldavite had been found in a factory zone instead of a field, would anyone have questioned that assumption? Or was its dismissal rooted in how much it didn't look like what experts expected? For years, Moldavite sat in museum drawers and private collections under vague labels. Interesting, perhaps. Unusual, certainly, but not something most experts felt compelled to defend. Then came the data. As analytical techniques improved, researchers began noticing patterns that glass simply shouldn't have. Chemical compositions that didn't match known industrial materials. Isotopic signatures inconsistent with human-made glass, and distribution patterns that raised deeper questions. Eventually, the explanation became impossible to ignore. Moldavite wasn't industrial glass at all. It was tektite, formed when a massive meteorite impact melted terrestrial material and hurled it across the landscape at extreme speeds. The result wasn't crystal growth. It was instant transformation, heat, pressure, velocity. Moldavite's irregularity wasn't evidence of fakery. It was evidence of violence, geological violence on a planetary scale. That realization forced experts to confront something uncomfortable. The stone had been misclassified not because it lacked evidence, but because it didn't fit the visual language of gemstones they trusted. Once Moldavite's origin was accepted, its status shifted rapidly. Museums relabeled specimens. Academic papers reframed decades of assumptions, and collectors began looking at the stone not as flawed glass, but as one of the few gemstone materials directly linked to a known cosmic event. Still, skepticism lingered. Even today, Moldavite divides opinion. Some see it as a reminder that beauty doesn't require polish. Others still struggle with the idea that something so rough could be genuine. And that tension is exactly why Moldavite belongs on this list. Because it wasn't rejected due to lack of science. It was rejected because it challenged visual expectations. So here's the question that still unsettles experts and collectors alike. And I want your answer in the comments. If a gemstone doesn't look like one, does that make it less real or more honest? Ranked 8th, Tanzanite. The stone experts thought was too perfect to be real. Tanzanite entered the gem world under suspicion. Not because it looked cheap, not because it lacked appeal, but because it appeared too perfect, too suddenly to be natural. In the late 1960s, when blue-violet crystals began surfacing near Mount Kilimanjaro, many experts were skeptical from the start. A gemstone with this color, this clarity, and this intensity had simply never been documented before, and that raised a red flag. At the time, gemstone history followed a predictable pattern. Valuable stones were known for centuries. They appeared slowly. They earned trust over generations. Tanzanite broke that pattern completely. It arrived all at once, from a single small region, with colors that rivaled sapphire, sometimes surpassing it. To some experts, the conclusion felt obvious. This had to be treated, enhanced, or artificially induced. A stone this striking couldn't simply appear out of nowhere. Here's the first uncomfortable question experts avoided. If Tanzanite had been discovered centuries earlier, would it have been doubted at all? Or was suspicion driven by timing rather than evidence? Early skepticism focused on its color. Tanzanite displayed strong pleochroism, shifting between blue, violet, and sometimes burgundy, depending on angle and light. To many gemologists at the time, this behavior looked engineered. Some believed the stone was a heat-treated variant passed off as something new. Others suspected laboratory intervention. But again, the problem wasn't deception. It was unfamiliarity. As testing became more precise, Tanzanite revealed its true identity. It wasn't synthetic. It wasn't an invention. It was a naturally occurring blue zoisite, colored by vanadium, an element rarely present in gem quality concentration. Its color wasn't added. It was unlocked. Natural heat from geological processes, and sometimes minimal disclosed enhancement, brought forward hues that had always been there. Nothing artificial, nothing fabricated, nothing fake. Once experts accepted this, resistance faded quickly. Tanzanite was officially classified, studied, and integrated into gemology texts. Its single-source origin, limited to a narrow strip of land in Tanzania, shifted from a liability to a defining feature. But the early doubt left a mark. Even today, some collectors feel uneasy about Tanzanite, not because of evidence, but because of how quickly it rose. It didn't earn trust through age, it earned it through verification. And that distinction matters. Tanzanite wasn't rejected because it failed science. It was doubted because it arrived before tradition was ready. Which brings us to a question worth asking. And I want your honest take in the comments. Should a gemstone be trusted because it's old or because it's proven? Ranked 7th, Paraiba Tourmaline. The neon color experts refuse to believe. Paraiba Tourmaline didn't just raise eyebrows. It crossed a line experts weren't prepared for, because gemstones weren't supposed to glow like this. When intensely bright blue-green tourmalines began appearing in Brazil in the late 1980s, the reaction wasn't excitement. It was disbelief. The color was electric, almost luminous, so saturated it looked artificial even under neutral light. To many experts, the conclusion felt unavoidable. No natural gemstone should look like this. At the time, gemstone color followed familiar rules. Vibrant, yes, but never neon. Stones that appeared this bright were usually treated, dyed, or engineered. And Paraiba Tourmaline looked like it had skipped every natural limit experts trusted. Here's the first uncomfortable question experts avoided. If a stone looks artificial to the trained eye, should science follow appearance or challenge it? Early analyses only deepened suspicion. The glow didn't fade under different lighting. The color remained shockingly intense even in small sizes. Some experts quietly assumed undisclosed treatment. Others suspected a new form of enhancement that hadn't yet been documented. No one wanted to be the first to say it was real, because if Paraiba was natural, it meant something unsettling. Gemological color theory was incomplete. The turning point came not from surface inspection, but from chemistry. Advanced testing revealed unusually high concentrations of copper, an element rarely present in tourmaline, and almost never at levels capable of producing such saturation. The color wasn't added, it wasn't amplified, it was generated from within the crystal lattice itself. The glow wasn't artificial, it was structural. Paraiba Tourmaline wasn't breaking the rules. It was revealing rules experts hadn't known existed. Once copper's role became undeniable, resistance collapsed. What had been dismissed as too much was suddenly understood as a geological anomaly, the result of a highly specific environment that nature had repeated only a handful of times. But by then, the damage to trust had already happened. Paraiba didn't spend years earning belief. It had to force acceptance, and even today its reputation remains complicated. Many collectors still pause when they see that color, not because they doubt the science, but because their instincts haven't caught up with it. That hesitation is exactly why Paraiba belongs on this list. It wasn't rejected because it lacked evidence. It was rejected because it looked like something nature wasn't allowed to make. And that raises a question worth answering. And I want you to weigh in below. When a gemstone defies what experts expect, should disbelief last longer than the proof? Ranked 6th, Benitoite. The blue experts mistook for something else. Benitoite wasn't dismissed because it looked ordinary. It was dismissed because it looked too familiar. When intensely blue crystals began appearing in California in the early 1900s, many experts assumed they already knew what they were looking at. The color was unmistakable, deep, vivid, almost electric. To trained eyes, there was only one logical conclusion. This was sapphire, or at least something pretending to be one. At the time, sapphire defined true blue in gemstones. Anything that matched that color was either sapphire or an imitation trying to pass as it. And Benitoite's brilliance immediately raised suspicion. Here's the first uncomfortable question experts never pause to ask. If a stone perfectly matches something we already know, do we still bother to question it? Early examinations reinforced the mistake. The color fit expectations. The sparkle was intense. And because experts believed they were looking at sapphire, no one thought to test beyond that assumption. But something didn't quite align. The crystal shapes were wrong. The optical behavior didn't match. And under closer observation, the stone behaved differently under light. Still, the default assumption held. If it wasn't sapphire, then perhaps it was synthetic, or worse, a clever imitation, because the alternative was unsettling. It would mean a completely new gemstone had been hiding in plain sight. The turning point came when detailed mineralogical analysis finally broke the illusion. Benitoite wasn't corundum. It wasn't glass. It wasn't an imitation of anything. It was a new mineral species, chemically and structurally distinct, unrelated to sapphire, naturally formed under extremely specific geological conditions. The blue wasn't borrowed, it was intrinsic. Once that realization took hold, disbelief gave way to embarrassment. Experts hadn't been fooled by fakery, they had been fooled by familiarity. The stone looked too much like something they already trusted, so they stopped questioning it. Benitoite's classification forced a quiet reckoning. How many times had experts mistaken similarity for identity? How often had something new been ignored because it resembled something old? Over time, Benitoite earned its place, not through hype or promotion, but through verification. It became recognized as a legitimate gemstone and eventually designated a state gem, not because of popularity, but because of rarity and scientific significance. Yet its story remains a warning. Benitoite wasn't rejected because it failed tests. It was misidentified because experts assumed they already knew the answer, and that assumption cost it years of recognition. So here's a question worth asking, and I want your honest take in the comments. When something looks exactly like what we expect, are we more likely to understand it or overlook it? Ranked 5th, Blue John Fluorite. The stone experts dismissed as too soft to matter. Blue John Fluorite wasn't doubted because it looked fake. It was doubted because it looked unimportant. In classical gemology, hardness mattered. Permanence mattered. A real gemstone was expected to survive time, wear, and pressure. Fluorite failed that test almost immediately. It was too soft, too fragile, too easily scratched. So when banded blue and gold fluorite began attracting attention in England, most experts didn't argue about its authenticity. They simply dismissed it. Why bother classifying something that couldn't endure? Here's the first uncomfortable question experts never asked. If a stone can't survive daily wear, does that make it less real or just less useful? For decades, Blue John Fluorite was treated as decorative at best. Beautiful, yes. Scientifically interesting, perhaps. But gemstone worthy? No. It didn't fit the hierarchy experts relied on. Hard stones rose to the top. Soft stones were pushed aside. And Blue John paid the price. Its visual qualities didn't help its case. The banding was dramatic. Deep purples, yellows, and blues, woven together in patterns so striking they almost looked artificial. To some eyes, the colors felt exaggerated, manufactured, suspiciously perfect. But again, the issue wasn't fakery, it was classification bias. As mineralogical study advanced, experts began re-evaluating materials that had been excluded, not for being false, but for being inconvenient. Blue John Fluorite was one of them. Testing confirmed what miners and craftsmen had known all along. The banding wasn't painted. It wasn't layered by hand. It was the result of natural growth conditions that occurred in a very specific geological window, one that had already closed. Blue John wasn't just natural, it was finite. Once that reality became clear, perception shifted. What had been ignored as too soft suddenly became irreplaceable, not because its hardness changed, but because its scarcity was finally understood. There would be no new supply, no second discovery, no replacement, and that changed everything. Museums began protecting existing specimens. Collectors stopped treating Blue John as disposable. Craftsmen who once worked it freely realized they were handling a material that would never be replenished. Experts hadn't been wrong about its fragility. They had been wrong about its value. Blue John Fluorite belongs on this list because it reveals a quiet mistake experts made again and again, equating durability with legitimacy. But nature doesn't care how well something survives a ring setting. It only cares whether it formed. And Blue John did, once, briefly, and never again. Which brings us to a question worth answering, and I want your perspective in the comments. Should a gemstone be judged by how long it lasts, or by how rare its moment of formation was? Ranked 4th, Alexandrite. The color change experts thought had to be a trick. Alexandrite didn't confuse experts because it looked ordinary. It confused them because it changed its mind. Under daylight, it appeared green. Under candlelight, it turned red. To early gemologists, that behavior felt impossible. Stones didn't do that, at least not naturally. Color was supposed to be stable, a fixed identity, not a moving target. So when Alexandrite first entered expert circles in the 19th century, suspicion followed immediately. Here's the first uncomfortable question experts struggled with. If a gemstone changes color on command, is it still a gemstone or a performance? At the time, color manipulation was already known. Dyes, coatings, and optical tricks existed, and Alexandrite's transformation looked too dramatic to be trusted. Some experts assumed layered materials. Others suspected clever lighting tricks or early enhancement methods, because the alternative was unsettling. If Alexandrite was natural, then color, one of gemology's most reliable anchors, wasn't as reliable as experts believed. Early testing only added confusion. Alexandrite didn't behave consistently across light sources. The same stone could look entirely different within minutes. That variability clashed with how gemstones were categorized and valued. So doubt lingered. For years, Alexandrite was treated with caution. Admired, yes, but not fully trusted. Its beauty was undeniable. Its explanation was not. The breakthrough came when experts stopped focusing on what the stone looked like and started asking why. Spectral analysis revealed the answer. Alexandrite's crystal structure absorbed and reflected different wavelengths depending on the light source. It wasn't changing color. It was responding honestly to the environment. The stone wasn't deceptive. Human lighting was. Nothing was added. Nothing was altered. Nothing was staged. Alexandrite's behavior wasn't a trick. It was physics. Once that understanding took hold, resistance collapsed. What had been dismissed as theatrical became one of the most celebrated optical phenomena in gemology. But the initial skepticism left a lesson behind. Experts hadn't doubted Alexandrite because it lacked evidence. They doubted it because it challenged a rule they relied on. That color equals identity. Alexandrite proved that identity could be conditional, and that idea made experts uncomfortable. Even today, Alexandrite unsettles people, not because it's misunderstood, but because it refuses to be pinned down. It doesn't perform for light, it reacts to it. That's why Alexandrite belongs so high on this list. It wasn't rejected for being false, it was doubted for being too responsive. Which brings us to a question worth answering, and I want your honest take in the comments. If a gemstone reveals different sides depending on the light, is that inconsistency or deeper truth? Ranked third, Grandidierite, the stone experts thought was too rare to be real. Grandidierite didn't enter gemology with excitement. It entered with doubt, not because it lacked beauty, not because it behaved strangely, but because almost no one had ever seen one. When early specimens appeared, experts hesitated. A gemstone with this color, blue-green, slightly smoky, sometimes glowing from within, should have left a trail. Mines, records, trade history. Grandidierite had none of that. Here's the first uncomfortable question experts avoided. If a gemstone truly exists, shouldn't there be more of it? At first, Grandidierite seemed to break a fundamental assumption in gemology. Rarity has limits. Stones can be uncommon, yes, but this uncommon, some experts quietly suspected laboratory origins. Others assumed misidentification. A stone that appeared this clean, this saturated, and this scarce felt more like a controlled experiment than a natural product. And because so few transparent specimens existed, doubt grew louder. For years, Grandidierite lived in footnotes, mentioned briefly, labeled cautiously, often accompanied by qualifiers like extremely rare or questionable transparency. Not fake, but not fully trusted. The deeper issue wasn't chemistry, it was probability. Experts weren't asking whether Grandidierite could exist. They were asking whether nature would bother making it. That skepticism began to unravel when more rigorous mineralogical work was applied. Chemical analysis confirmed a unique composition. Optical testing showed consistent behavior. Crystal structure matched natural formation patterns. There was no lab shortcut, no synthetic workaround, no artificial signature. Grandidierite wasn't rare because it was engineered. It was rare because its geological recipe was brutally specific. Pressure, temperature, elemental balance. Miss any one of those and the stone simply wouldn't form. Once that reality set in, perception shifted. Slowly, then all at once. Grandidierite moved from suspicion to reverence. Not because experts suddenly liked it, but because the evidence left no room for dismissal. The stone wasn't improbable, it was inconveniently real, but its early rejection left a lasting lesson. Experts hadn't doubted Grandidierite because it failed tests. They doubted it because it challenged their sense of scale. It was too rare to feel comfortable. Even today, Grandidierite unsettles collectors, not because they think it's fake, but because its existence feels almost unreasonable. And that's exactly why it ranks this high. Because Grandidierite wasn't dismissed for being false, it was dismissed for being statistically uncomfortable. So here's the question I want you to answer in the comments. When something exists in vanishingly small numbers, does that make it harder to believe or more meaningful? Ranked second, Taaffeite, the stone. Experts thought shouldn't exist. Taaffeite didn't arrive through discovery. It arrived through disbelief, because no one was looking for it. In fact, experts were convinced it couldn't exist at all. When a pale violet gemstone surfaced in a parcel of cut stones in the mid-20th century, it was initially dismissed as something familiar. Perhaps spinel, perhaps a miscut sapphire. Nothing worth slowing down for. After all, the stone wasn't found in a mine. It wasn't documented in the ground. It appeared already cut, already polished, and that immediately raised suspicion. Here's the first uncomfortable question experts avoided. If a gemstone has never been found in nature, can it still be natural? At the time, gemology relied on a simple assumption. Stones are discovered in the earth first, then cut. Anything that appeared in reverse order felt artificial by default. Taaffeite violated that logic. Early testing produced an even bigger problem. The stone didn't match known properties of spinel. Optical behavior was off. Refractive readings didn't line up. Chemical signatures refused to cooperate with existing classifications. For many experts, the conclusion was easier than the explanation. This had to be synthetic, because accepting the alternative meant something far more disruptive, that an entirely unknown gemstone species had slipped through the system unnoticed. And systems don't like that. For a while, Taaffeite existed in a kind of academic limbo, too real to ignore, too inconvenient to accept. It wasn't labeled fake outright. It was quietly sidelined as an anomaly. But anomalies have a way of demanding attention. As more detailed analysis was applied, the stone's identity became impossible to deny. Taaffeite wasn't a variant. It wasn't a treatment. It wasn't a lab creation. It was chemically and structurally distinct. A gemstone no one had predicted, but nature had quietly produced anyway. That realization forced experts to confront a deeply uncomfortable truth. Their knowledge wasn't incomplete because of lack of effort. It was incomplete because of assumption. They had believed they already knew the full list. Once Taaffeite was recognized, the irony deepened. Natural crystals were eventually found, but in such small quantities that the original doubt almost felt justified. Almost. Taaffeite wasn't rare because it was artificial. It was rare because it formed under conditions so narrow that it barely left a footprint. And that rarity explains why experts missed it. But it doesn't excuse the dismissal. Taaffeite ranks this high because it exposes one of the most dangerous expert biases of all. The belief that what hasn't been seen yet can't exist. This stone didn't fail science. Science failed to imagine it. So here's the question I want you to answer in the comments. If something appears before experts are ready to explain it, should it be rejected or investigated? In first place, Painite, the stone experts were sure couldn't be natural. Painite didn't just confuse experts, it embarrassed them. For years, Painite existed as a contradiction, a gemstone so rare that many experts quietly assumed it couldn't be real at all. When the first specimen surfaced in the mid-20th century, disbelief came naturally. Not because the stone behaved strangely, not because it showed obvious signs of fabrication, but because there were almost none of them. One specimen, then another, and then Nothing. Here's the first uncomfortable question experts avoided. If nature truly created this stone, where were the rest? Gemology relies on patterns, deposits repeat, crystals cluster. Even the rarest minerals leave traces. Painite didn't. For decades, it appeared to exist as isolated examples. Too few to feel geological, too clean to feel accidental. To some experts, the simplest explanation felt safest. Laboratory origin, because believing painite was natural meant accepting something deeply unsettling, that nature could produce a gemstone and then almost completely erase the evidence. Early analysis didn't help. Painite's chemical composition didn't fit neatly into existing categories. Its properties overlapped familiar minerals, but never aligned perfectly with any of them. That ambiguity made dismissal easy. It wasn't labeled fake publicly, it was labeled impossible privately. Painite became a curiosity, mentioned cautiously, footnoted often, trusted rarely, not because evidence was missing, but because abundance was. Then the assumption broke. As exploration expanded and analytical methods improved, new painite crystals were discovered. Not many, but enough. Enough to establish a pattern. Enough to confirm formation. Enough to prove that the stone wasn't an anomaly or a mistake. It was a mineral species that existed on nature's narrowest terms. Painite wasn't rare because it was artificial. It was rare because its formation required a combination of elements and conditions that almost never aligned. Once that was accepted, the narrative flipped. The stone that couldn't exist became one of the clearest examples of expert overconfidence. Painite hadn't failed tests. Experts had failed patience. And that's why painite ranks number one. Because no other stone on this list was dismissed so confidently or proven wrong so completely. Painite didn't challenge gemology by being flashy. It challenged it by being scarce beyond comfort. Even today, painite carries that tension. Not because its authenticity is questioned anymore, but because it reminds experts of a truth they prefer to forget. Nature doesn't owe us quantity, or repetition, or reassurance. Sometimes it produces something once, and that has to be enough. So here's the final question I want you to answer in the comments. If a gemstone exists in numbers so small they defy expectation, does that make it less believable or more extraordinary? What these stones share isn't rarity, it's rejection. They weren't dismissed because they were fake. They were dismissed because they didn't fit what experts expected. And history shows something uncomfortable. Sometimes certainty delays truth. So here's my question for you. Which stone on this list surprised you the most, and why? Leave your answer in the comments. And if you want more stories like this, you know where to find us.